Everyone, today I am going to explain the example of Fourier expansion of even function. Here f of x is given. F of x is equal to x where x lies between minus pi to pi. We know that the f of x is equal to x square is a even function because when we put minus x, then x square remain x square. F of x is equal to f of minus x. Therefore, f of x is even function, therefore bn is equal to 0, therefore we will not take the bn into sin x. Therefore the Fourier expansion formula of f of x is equal to x square a naught by 2 plus summation of from n is equal to 1 up to infinity of n cos x. Then we will find the a naught and a n. Then first we will find the a naught. The formula for a naught is equal to 1 upon pi from minus pi up to pi integration of f of x with respect to dx. Here f of x is equal to x square. Then we will write 1 upon pi integration from minus pi up to pi x square integration. Here we take it integral from 0 to pi and then we have get 1 upon pi the integration of x square with respect to dx. The integration of x square is x cube upon 3. Limit varies from 0 to pi. Then we will put the limits of pi cube upon 3 minus 0. Then a naught will become 2 upon pi cube upon 3. Pi will cancel 2 pi square upon 3. Here we have get a naught.
So previously we have found out a naught, now we have to find out an. So the formula for an is pi integration of 0 to pi f of x dot cos of nx into dx. So the given is, so we'll put f of x is equal to x square. Solve this integration by Leibniz theorem. So x square will be considered as u and cos of nx will be considered as v. Now I will simply put the limits in the given values. If we put 0, so the all values will get 0. So simply write 0 here. So here, as we know, sin of nx will be 0. So this term will be 0, and this term will also 0. So the term remaining will be this. So the value of cos n pi is minus 1 raised to n. So I will write minus 1 raised to n upon n square. So the final equation will get as n is equal to so this is the value of an. So we have to put an, a naught and an in the Fourier series expansion. By Fourier series expansion, that is f of x a naught by 2 plus summation of n is equal to 1 to infinity an cos of nx. By putting the values of a naught and an, we will get this equation. By solving this summation, we will get this required Fourier series expansion.
Required Fourier expansion. For getting first result, we put x is equal to pi in equation 1. So we get value of first pi is minus 1. So first 2 pi is 1, plus 4 pi is 1. So we get, we take common minus sign, so we get when this term is shift here, so we get this 4 is divided here, and finally we get this is our required first result. So we give equation number 2. Getting second result, we put x is equal to 0 in equation 1. So we solve by previous example and we get answer like this is required second result. So we give equation number 3. For we are adding the equation number 2 and 3. When we add, then even terms are cancelled out and we get when we add this term, we are taken common out 2, so we get, so this 2 is divided here, so we get this is the required third result.
Now we will come up here with our second question. In this question, there are two functions. This function lies between minus pi to 0 and 1 minus 2x upon pi lies between 0 to pi. So now we will check either the function is even or odd. So for that, we will simply replace x by minus x. So f of n now, when we will multiply the negative sign to these limits, so the signs will change. So as you can observe, f of x and f of minus x, after replacing the signs, they both are equal. So therefore, f of minus x is equal to f of x. So therefore, this function is even function. So for the even function, as you know, bn is equal to 0. So now we will find the values of a0 and a. So as you know, the formula of a0 is, here you can see from the limits 0 to pi, the value of the function is 1 minus 2x upon pi. So we will simply put that value. Now just we'll perform the integration. So as you know, the integration of 1 is x and that of so this is and limits from 0 to pi. Now we will put the values of the limits. So as we will put the pi, so pi minus pi square upon pi, that is pi. So pi minus pi will be 0. So 0 into any number is 0. So therefore a0 is 0.
So we are to find out of value of an. So it is the formula of an. So 2 by pi integration of 0 to pi f of x cos nx into dx. So f of x value is put this equation. So 2 by pi 0 to integration of 0 to pi 1 minus 2x by pi. So cos nx into dx, it is integration of u into v. So solved by Leibniz theorem. So 2 by pi. So 1 minus 2x upon pi value is as it is, and integration of cos nx upon dx, it is sin nx upon n, and derivative of 1 minus 2x by pi, it is a 2 by pi, and integration of sin nx upon n, it is a cos nx upon n square. So bracket 0 to pi, put the limit of pi. So cos n pi, the value of minus 1 raised to n upon n square. Put the lower limit of 0. So put the value of sin n 0, value is 0, and cos 0 is 1, and so value of 2 upon pi n square. If the 2 is common, and so value of 4 upon pi square. So bracket of 1 minus bracket of minus 1 raised to n upon n square. So an value is if n is even number, then 0, and if n is odd number, so 8 upon pi square of n square is. So thank you.